Okay, as I said a couple of times previously, a cosh curve is really important because it models the shape of a free-hanging cable. So this is an example where we've got a cable hanging between a couple of pylons over a lake, and the shape of the cable is modelled by this equation here. And the question is to find how far out from the centre. So on a set of axes, that would be the y-axis, and it would be the x-axis. So how far out from the centre is the cable at a height of 80 metres is the question we've been asked to answer. So we just want to find when y equals 80 to solve this equation. So I've rewritten the equation down the bottom here, and I've gone through the simple process of getting cosh by itself. Now, one way of dealing with this is to write your cosh as its exponential function. So that's e to the power of x plus e to the power of minus x over 2 equals the number we're dealing with here. And then we're going to do the same as we did when we solved that equation previously, and that we're just going to multiply the 2 up and make it effectively into a quadratic equation. So I'll just do it in 2 steps. So e to the x plus e to the minus x minus 2.00901, we'll call it 2, equals 0. And then we're going to multiply everything through by e to the power of x. So we end up with e to the power of x squared minus 2.00902 e to the x plus 1 equals 0. And the way we're going to solve that thing is by using the quadratic formula. So that's here in the other simple way to factorise that lot. So the quadratic formula tells me that e to the x is negative b 0.00902 plus or minus the square root of b squared minus 4 lots of a times c, all of that divided by 2 lots of a. And if I crunch that through the calculator, I get 0.9046 or 1.099576, I think, if I use those two numbers into my calculator. So x equals the natural log of those two things. So if I do the natural log of this number, I get negative 0.094. If I do the natural log of this number, I get positive 0.94, which is good. So I've got symmetrical answers because the line's going to be 80 metres above the water level, evenly spaced on either side. And I just need to check because x was in kilometres. It said at the top there. It's going to shoot up. X is measured in kilometres, so these two answers are in kilometres. So x equals, you put it back into metres, 94.9 metres either side of lowest point. Okay, so that's how you do it. Longhand, you could jump in and use the calculator just straight at this point here, because at that point there we're told that the cosh of x is 1.04509, so we could just use the calculator and do the inverse cosh of that number. So let me just show you how to do it on the calculator. So on the calculator you've got a cost button and an inverse cost button, but you also got this hype button, which is the hyperbolic sign. So to an inverse cosh, you need to go shift for the inverse, hype cost, and you should find your calculator tells you cosh inverse, and we'll put the number in. So the number is 1.004509, and the answer is 0.0949. Exactly the answer we got before. So you can just use your calculator to do an inverse cosh. So if an exam question just asks you to solve this, you'd use your calculator for inverse cosh, but the exam question may ask you to do it by the exponential definitions.